Have you ever just looked up at the night sky and wondered, where did all of this come from? Or even bigger, where did I come from? Well, today we're going to go on a journey, a trip through space and time to uncover your cosmic origin story. It's this amazing, interconnected tale that stretches from the fiery hearts of dying stars to the birth of our own planet, and all the way back to the very first moment of the universe. All right, let's get into it.
You know, this is probably one of the most mind-blowing ideas in all of science. And the amazing part is, it's absolutely true. The atoms that make you, the iron in your blood, the calcium in your bones, they weren't made here on Earth. Nope, they were forged billions of years ago inside the nuclear furnaces of stars that lived and died long before our sun was even a twinkle in the galaxy's eye. So in a very, very real way, we come from the stars.
So if we want to understand our story, we've got to start with theirs. We need to take a look at the life and death of a star because these things are basically the cosmic factories that build all the essential elements for, well, for everything we know, including life itself. Every single star out there, and that includes our very own sun, starts its life right here, inside one of these, a nebula. Just look at it. They're these unbelievably huge, beautiful clouds of dust and hydrogen gas. And they're perfectly nicknamed stellar nurseries, because this is exactly where new stars are born. So how does a star actually, switch on? Well, it all kicks off with gravity. First, some part of that giant cloud gets dense enough that it starts to pull all the gas and dust inward, collapsing in on itself. As all that material rushes in, it starts spinning faster and faster, heating up like crazy at the center. That hot, glowing ball is called a protostar. But the final step, that's where the real magic happens. When the pressure and the temperature in that core get just ridiculously high, we're talking millions of degrees, nuclear fusion kicks in. Hydrogen atoms start smashing together to make helium, and that releases a truly massive amount of energy. And just like that, a star is born and begins to shine.
But a star's birth is really only half the story. Just like us, stars have a life cycle. And let me tell you, their death is one of the most violent and creative events in the entire universe. Because, as we're about to see, a star's death isn't really an end at all. It's actually the start of something totally new.
And here's the key thing to remember. How a star dies depends entirely on how much stuff it started with, its mass. A little low-mass star will just sip its fuel for maybe 100 billion years before it quietly fades out into a white dwarf. Our sun, which is a medium-mass star, has a shorter lifespan, about 10 billion years. Eventually, it'll puff up into a red giant before it also shrinks down into a white dwarf. But the really massive stars, the heavyweights, they go out with a bang. And this is that bang, a supernova. This is the spectacular, incredibly violent death of a star that's way, way bigger than our sun. When these giants run out of fuel, their core just collapses in an instant, and that triggers an explosion so powerful it can briefly outshine its entire home galaxy. It is truly one of the most energetic events in the whole cosmos.
And here's the most important part of our story. This incredible destruction is also a moment of pure creation. The unbelievable energy from that supernova forges all the heavier elements, things like iron and gold and oxygen, and then it blasts them across the galaxy at incredible speeds. This stardust is what enriches the next generation of nebulas, providing all the raw materials for new stars, new planets, and eventually, for us.
But what about the core of the star that exploded? What's left behind? Well, it faces one of two pretty wild fates. If the original star was, say, 10 to 40 times the mass of our sun, its core gets crushed down into a neutron star. This thing is so unbelievably dense that a single teaspoon of it would weigh billions of tons here on Earth. But if the star was a real monster, more than 40 times the sun's mass, the core collapses completely and becomes a black hole, a place where gravity is so strong that once you're in, nothing, not even light itself, can ever get out. Okay, so we've seen how stars live and die, and how in death they create all the elements that make up you, me, and everything else. Now let's zoom the camera out a bit and see how all that leftover stardust can come together to form a brand new solar system, one just like ours. It's a great question, right? All that incredible star stuff doesn't just drift around in space forever. Just like in those stellar nurseries we saw, gravity starts to work its magic again, pulling all that enriched dust and gas together to form a whole new cast of cosmic characters. And this is what you get. You've got your main attractions, the planets, which have their own orbits around the new star, But you also get a whole ecosystem of other stuff. You've got natural satellites or moons orbiting the planets. You've got tons of rocky asteroids, most of them hanging out in a belt between Mars and Jupiter. You've got icy comets that swing in from the far edges of the system. And of course, you've got countless smaller bits of rock called meteoroids zipping all over the place. Now, the planets themselves kind of fall into two distinct families. Close to the sun, where it's a lot warmer, you get the rocky, terrestrial planets like our Earth. They're smaller, they're denser, and they have solid ground you can actually stand on. Then, way out past the asteroid belt, you have the gas giants. These guys are enormous, much less dense, and they're mostly made of gas. There's no solid surface there at all. And just so we're all on the same page, in our solar system, the official planet count is 8. Yeah, 8. I know a lot of us grew up learning there were 9, but back in 2006, poor Pluto was reclassified as a dwarf planet, which is a whole different category of object. So we've gone from a single atom inside a star all the way to an entire solar system. But there is one last final step we have to take on this journey. We've got to ask the biggest question of them all. I mean, think about it for a second. This whole cycle of star birth and star death, it couldn't have just been going on forever. It had to start somewhere. To answer that question, we have to rewind the clock all the way back to the beginning of, well, everything. And this is our best scientific answer right now, the Big Bang Theory. Now, it's really important to note this wasn't some kind of explosion in space. It was the beginning of space itself, and time, and matter. The theory says that about 13.8 billion years ago, the entire universe was crammed into a single point that was unbelievably hot and dense. And from that very first moment, it has been expanding and cooling down ever since. So you might be wondering, how can we be so confident about something that happened so long ago? Well, the theory is held up by two huge pillars of evidence. First, back in the 1920s, an astronomer named Edwin Hubble noticed that almost every galaxy is moving away from us, and the farther away it is, the faster it's moving. That's the classic sign of an expanding universe. And second, our radio telescopes can actually detect this faint uniform glow of microwaves coming from every single direction in space. It's called the cosmic microwave background, and it's basically the leftover heat, the afterglow, from that initial super hot beginning. So, from the Big Bang to the very first stars to the supernova explosions that scattered the elements of life all across the cosmos, to the formation of our planet, and finally to you, sitting here listening to this right now, it's all one single unbroken story. We are the direct result of 13.8 billion years of cosmic evolution. You could even say that we're the universe becoming aware of itself. So the only real question left is, where do we go from here? What's the next great discovery we should be looking for?